Hey, hi friends, very good morning to everyone. So, so today we are going to talk about Oracle Data Guard. So maybe for the next 4 to 5 days we'll talk about this. What exactly is this data guard, how we are going to implement it, and what kind of real-time issues that we might face and how to fix them. So we will see all those things. So before going into more about the Oracle Data Guard, so we just need to understand the basic two terminologies. One is called as disaster recovery, and the second one is called as business continuity plan. So the first one is called as disaster recovery. So what could be a disaster? A disaster could be anything that interrupts the regular functionality of a system. So either it could be a database, or it could be a server, or it could be a network, whatever it is. So which is actually interrupting the regular functionality, we call that as a disaster. And there could be several reasons that a disaster will occur, like there could be fire accidents, or there could be an earthquake, or there could be a tsunami alert, or it could be uh, you know if a war that happens between two countries or whatever, or it could be a human error as well. So wherein one person by mistakenly removed some files, or one person by mistakenly shut down the server. So all this comes under the disasters. So how we are going to recover very fast when a disaster occurs is what we call that as the the business continuity plan. So shortly we call that as BCP. So the main purpose of having a business continuity plan, as I said, how fast the users will be able to again access the database or again access the server is what is really matters in today's world, because almost all the databases are running 24/7, irrespective of whether it is a critical application or a non-critical application, because the world is changing towards online mechanism, like all our payments or whatever is happening online nowadays. So the need of 24/7 up and running database has been increased. And because of the reason, when something happens to one database, the things should not stop there and it should proceed. Otherwise, it may lose its customers. So, for example, if you take an health insurance policy, like you purchased an health insurance policy from a particular company, and you need to do the uh, renewal payment, like premium payment every year. So let's say you tried to access that particular website this year to make your payment, and you found that that particular website is down for some reason, or that particular database is not accessible for some reason. So you would be waiting for some time, like maybe 1 day, 2 day, 3 days, and again you will try once again to access that particular site. So if it is still down, then generally, I mean, if it is happening repeatedly, people will get frustrated, and maybe they will change their account from that particular policy to some other company. So, like you will be moving from some X company to Y company, which means that X company is losing a customer and Y company is gaining a customer. So maybe in these kind of things like health insurance or bank accounts and all, maybe this switching is not that much easy as we discussed. But taking an example of anything that you are trying to purchase online. So let's say you are trying to place an order on Amazon, and due to some reason that order is not being placed. In that case, you will not wait for some time. Like if you feel that some other website is also uh, providing good service and it is also having the same price what Amazon is offering, then immediately you will go ahead with that particular website and you will order that particular item. So here in this case, especially when you are doing online purchases and all, so things should be very fast. Like I mean to say, customers will not wait for that particular company for a long time because they are having lot many opportunities outside. So that's the reason having a 24 bar 7 database without any disturbance has become the primary goal for any company now, because they want to basically retain their customers. So for that, I mean, if it is a normal thing, it's okay, we can maintain it. But as I said, when we have a disaster, how we are going to uh, recover our company from that particular situation? So that for that we are going to design a plan, so that we are going to define, okay, at this particular data center, if something goes wrong, so how I need to allow my users, or how I need to divert my users to connect to another server or another database which is located in a different country or different city. So that particular plan we are going to call it as business continuity plan. And this business continuity plan or disaster recovery plan is not only limited to the database, or not only limited to the database, servers or network. So it can be applicable even at the site level as well. So site level in the sense, to give you an example, suppose a company is having a branch in both Hyderabad as well as Bangalore locations. So, people will be distributing, I mean, some DBAs or some people working in Hyderabad and some people working in Bangalore. So all of a sudden, on a particular day, when you go to office, your management will declare an emergency situation. So it is a fake emergency situation only, but just to make sure that everything is going right, they will announce a emergency situation. So they will say that entire Hyderabad site is down. So nobody will be able to access the machines, or I mean, nothing is going to happen. Your entire location is down. So, and immediately you need to inform your Bangalore location, so that if something goes wrong, how you need to take care of those things and all. So Bangalore team will basically take care of the business continuity, like whatever the requirements that comes in. So they will take care of that particular services. So again, for this we can take a very good example. Few years back we had heavy floods in Chennai location. You might be knowing that through media. So, and you must be knowing that all the software companies almost closed down, like because there was a huge water clogging and all. So, but still in those situations, you might see that like no client has been affected with this thing. Why? Because some companies, because they have an alternative location as Hyderabad or Bangalore, the business continued as it is. Or some companies, what they did, they immediately, on the spot, they have created some alternative business continuity plan, and they had go ahead with that. So, and for this, there might be a requirement, like you might be hearing some companies, what they did, they have made the people who are located in Chennai to travel to Bangalore or Hyderabad for temporary time to work from there, work from that particular location. So this is also a kind of business continuity plan that we have. So by this you might have understand that basically to provide very good service to the clients, we have this option called business continuity plan or disaster recovery. And IBM is the first company to have designed the business continuity plan for its servers, and of course that has been followed by other companies as well. So IBM basically designed this thing for its servers, and it has been spread across other levels like network, database, then application. Even application team also will have a business continuity plan. So if one application server is down, how we are going to uh, make another application server available so that the things will continue as it is. So that's the basic idea over here. So Oracle has integrated that concept of business continuity to its database, and version by version things have been changing a lot. And like with the recent 12c version, we have lot many options, and the things have been very easy either to implement or manage. So that is what we are going to talk about, in these classes. So before jumping on to what is Oracle Data Guard, so we need to understand two terminologies basically. So the database, the production database, which generally users will connect, and they would do the transactions. So we generally call that as a production database. So when it comes to the data guard environment, the same thing we are going to call that as primary database. And when we are doing the configuration, we are going to create a replica of the primary database in a different location, which we call it as standby database. So whatever the transactions happens on the primary database will keep on replicating into the standby database, because the data should be in sync always. And this standby database, we have two types. One, we call it as physical standby database, and the second one we call it as logical standby database. So even when it comes to real time, there are very few environments which maintains the logical standby environment. So always they will go for physical standby database. So our concentration for the next few classes will be more on physical. But even we will talk about logical standby database, but practically we are not going to see the logical standby implementation. So we will see only the physical standby, because that is more important either for the interview point of view or even from the working point of view. So coming back here, as I said, we have primary and standby databases. Usually these primary and standby databases will be located in two different geographical locations. Like the primary could be in some one abroad country, let's say United States, and whereas the standby could be in some other country like UK, or it could be in some other country like uh, Singapore or Malaysia, whatever it is. Now, when you are creating a standby database, I mean, especially when this is there in designing phase and all, there will be some people called architects, technical architects, or database architect. So these people will go through the location analysis as well. So generally, the standby location will be chosen as the one of the safest place in the world. So what we mean by one of the safest place in the world? So they will choose such a location that it is not having much earthquakes in the last 10 or 20 years, or it doesn't have any terror attacks. Maybe, it's one of the safe places, or it doesn't have any major natural calamities happen, like, hit by tsunamis or fire accidents, most of the fire accidents or something like that. So, I mean, to not discourage, but just to give an example, we cannot really go and choose particular cities in Japan as the standby locations. Why? Because Japan is more prone for earthquakes. So such kind of locations cannot be chosen as the standby locations. So that is main important. The reason being choosing the safest locations is if both primary and standby is also down, then it would be a problem. So that's the reason even they will not choose this within the same country as well, or within the same geographical location as well. But even if they choose, it would be a very far place. So like suppose if the data center, if the primary database is available somewhere in let's say Portland, it's in United States. I believe it's in west northwest region. So if the primary database is there in that particular location, then they might choose uh, Florida as the standby location. So, because it is very far away in distance, and anything that happens should not really impact both of the databases. But of course, again, you might be recently hearing about the hurricane attack happens in Florida. So all these things will be considered while they decide what should be the standby location for the very first time. And people says one of the safest location in the world, or most of the primary databases have their standby locations in both Singapore and Malaysia. The reason being is all these factors, whatever we talked about, the natural calamities, uh, sorry, is very less when you look at those cities. Like maybe in the last 20 years, we never heard of having a major natural calamity occurred at Singapore or Malaysia regions. So that's the reason most of the databases are having their standby environments in these particular countries. Okay, so that's about the primary and the standby databases. So coming back to what exactly it is. Now, I am saying about a standby database, but here the word is showing as Oracle Data Guard. So what exactly is the difference? To maintain the standby database and to always monitor this primary database and standby database, we are going to create a particular component called observer. So this component is going to play a major role. Uh, so we'll be discussing more about it. So if you are having even observer in place, and you are going to use a utility called DataGuard Manager, which we shortly call it as DGMGRL, along with this observer, then we are going to call that as a DataGuard configuration. And these two are not mandatory. Having DataGuard Manager and Observer are not mandatory. So even you can run the show with only just the primary database and the standby database. So when you have this observer and data guard manager also in place in your architecture, then we call that architecture as Oracle Data Guard, or otherwise you just need to call it as the standby database. So coming back, there are few points over here for us, and yeah, we can have multiple standby databases as well. So 10G allows you to have 10 standby databases, whereas from 11G you can have 31 or 30 standby databases. So at different locations, but of course, maintaining those many databases is again a cost effective matter. So as per my experience, maximum in my experience, I have seen people maintaining three standby databases. That is the maximum thing that I have seen. That is for one of the very critical databases that I worked for. But or otherwise, generally we'll say only one database that will be maintained. And Oracle also provides an option that you can do a failover to the standby database automatically. Like if the primary database is not available due to some reason, then immediately, automatically, the standby database can be act as a primary database. Means the users will start connecting to the standby database to perform their transactions. So that can be configured either manually or automatically. So both are having their own advantages and disadvantages. When we come to that particular slide, we will discuss about that. So as I said, whatever the changes happen to the primary database are going to replicate to the standby environment. And as I said, there is whatever the human intervention is there, that could be reduced when you enable the automatic failover. And of course, there is no distance limitation. Like you can have primary in one location, and as I said, very far away in the other side of the world, you can have the standby database created. So what are the general reasons that we go for the data guard environment or the business disaster recovery environment? So these are the reasons, as I said: power failure, air conditioning failure, then flooding, fire, storm damage, etc., etc. So what exactly could be a standby database? So a standby database will have the same transactions, same data what a primary database is having, and with the copy of the primary database, like with the backup what we have in the primary database, we'll be able to create, as I said, up to 30 standby databases from 11G onwards. If it is a 10G database, it is only till 10 databases. And when it says once we have configured the Oracle Data Guard, so the maintenance of the standby database will be very easy. And this standby database can be created either for a standalone database like what we are seeing in our course now, or it can be done for a Oracle RAC database as well, wherein you have multiple cluster environment. And what will get replicated onto the standby database? So anything that you in the primary database, it will be replicated in the standby. Like at the schema level, you do any table additions or dropping of the table or inserting some rows, deleting some rows or updating some rows, or at the database level, you create some users, you grant some privileges, you revoke some privileges, you drop some users, or you create some new table spaces, you add some new data files, or you drop the existing table spaces. Like this, whatever you do at the structural level, all this will get replicated onto the standby environment. But the Unix level changes, whatever you do, will not get replicated. Like on the primary server, if you had a new mount point, like generally we have U01, U02, and U03. Let's say on the primary database server, you have added U04, like your OS team has added U04 mount point, that will not get replicated onto the standby. So on standby, if you want U04, again you need to manually do that. Same way, you do some changes in the P file or SP file of primary, it will not get replicated onto the standby. Or you change something in TNS names file, so that will also gets not replicated. So anything that you do at OS level, those things will not get replicated, and you need to make sure that you are doing this on both the sides. Like when you are adding a mount point, you need to make sure you are adding on both the servers. Or when you are changing something in tnsnames.tar file, you need to make sure you need to add that to the standby TNS names as well. And when it comes to patching or upgrading the databases, so well, even that will get replicated. So if you do patching on the primary database with the small modifications, automatically standby also will get replicated with that. And even during the upgrade as well. So those things also will get replicated. So what are the hardware requirements that we need in order to create a standby environment? So coming to hardware, it can be different between the primary and the standby systems, like the number of CPUs, the RAM size, or the storage capacity, whatever. In your primary server, if you have 128 GB RAM, it is not mandatory that in standby also you should have 128 GB RAM. You may have only 100 GB RAM as well. But generally, when it comes to real time, until unless client cannot afford that, you will not see this kind of situation. So whatever the configuration you have in the primary server, same configuration will be there in the standby as well. In primary, if you have 32 CPUs, standby also will have 32 CPUs. In primary, if you have, as I said, 128 GB RAM, then standby also will maintain that 128 GB RAM. So these things will be there similar or equal in both the environments, especially in real time. But what is mandatory is operating system. So you should have the same operating system, but from 11G onwards, Oracle has given us an option to have uh, what we call it as heterogeneous data guard environment, wherein your primary database can run on Oracle Linux, whereas your standby can be there in Oracle in Solaris. So like two different operating systems can be there, but still you can configure the data guard environment, but that's a kind of more complicated one. So that's the reason even in real time clients will not prefer to go for it. So generally they maintain the same operating system. And not only the same operating system, the version of the operating system or the patch level of the operating system also should be same. So let's say you are using Oracle Linux 7.3 or 7.4 version, and on primary there is one patch that was applied, because for operating systems also patches will be released. So you need to make sure on the same day that patch will be applied on the standby environment also. So always the operating system version including the patches should be same, so that there is no what we say complications occurs in future. So to give an example also, this recently we have faced one of the issues. So it happened to be like So in our environment, the things will be like the patching will be starting with the development environment, then they move to test environment, then production fix, then they do BCP first, then they do the primary. So BCP in the sense standby. So why? Because if we apply on primary, if something goes wrong, at least that will be impacted. So that's the reason. Usually, the good idea is to apply something on the BCP first, and on the same day, if everything is okay on the BCP, then we will go and move to the primary database. So what happened recently is on the BCP side, and it is merely a scheduling problem. So on Saturday of one weekend, the OS level patch has been applied onto the standby environment, and on Sunday they need to apply the same thing on the primary server. Now what happened is Saturday morning this patch has been applied at OS level, and Saturday afternoon there was a switchover activity. Switchover activity is nothing but changing the roles from primary to standby and standby to primary. So like primary will become the standby database and standby will become the primary database. So there was some activity planned. So because of small communication gap, so the person who is doing that switchover don't know that the standby environment has been patched that day morning. So as usual, he started doing the switchover, but there were a lot of errors and the things were not being proper. So after going through, after going through all the things, finally they have identified that it is because of the patching that this kind of issues came into picture. So then they waited for that switcher. I mean, they waited for Sunday. As I said, Sunday morning, again the patching happened on the primary database server. And once it is done, they performed the switchover, then everything went successful without any issues. So even a small patch also may impact the things. So that's the reason always we maintain the same version and same patch level for the operating system. And the servers could be either virtual or physical, that can be anything. So here it says that OS release does not need to be same, but frankly to say, when comes to real time, it should be same. And the directory structure does not need to be same. Like in the primary, if you have the naming conventions of your mount points as U01, U02, U03, etc., it is not mandatory that you need to have the same file system things naming conventions on the standby. On the standby, you may have different naming conventions for your mount point. Still then things will work. And when comes to database, what are the requirements? So of course your database must be in archeolog mode, and your database should be an enterprise edition database. So if you are using a standard edition database or a personal edition database, this creation of standby environment is not possible. So this feature is only available from enterprise edition onwards. So as I said, both the databases should be of same version and same patch level as well. And of course, it could be a single instance or it could be a RAC environment. So anyone having any questions before we proceed further? Okay, so let's move on. So this will be the generic architecture, but don't look at the diagram and come to some conclusions. So there are lot many things that we need to understand. So just want to show you what kind of different process or services involved in this data guard environment. So when some transaction is happening on primary, as I said, it is replicating onto the standby database means somebody should do the work in the background. And what are all the process that will do that work, or what are all the process that are involved in this? So all these process, one is log writer, then archiver, then we have something called log network service and remote file service. Then we have managed recovery process and logical standby process. So all these process will not be required. Depends on the architecture we use or depends on the mode we use. These things will be changing. So which we'll be discussing further. So this one, as I said, we have two different types of standby databases. One is physical standby database, so which is nothing but an exact replica of the primary database, and whatever the changes you do on the primary, it will get replicated onto the standby. And always this database will be running in recovery mode. So again, this is one thing that Oracle has brought in from version to version. So till 9i, you can have your standby database only in mount state. So there is no possibility that you can open your standby database. So you can have this only in the mount state. Or before going for it, let me give you a small background. So how the things will work to understand in a simple manner. So how the things will work, as I said, whenever you do some transaction in primary, I'm saying that will get replicated onto the standby environment. So how that will work? So let's say some users connected and they are doing some transactions. You know, it will generate redo entries, and those redo entries will come to redo log files. And if your database is in archeolog mode, they will come to archeolog files. So what we are going to do is, the very first time we are going to take a backup of the primary database and we will restore onto some other server, and we will create a similar database over there. Now whatever the changes happening on the primary are finally getting recorded onto the archive logs. So what we will do is, we will transfer those archive logs, or we will copy those archive logs onto the standby server, and from there we are going to keep on applying the archive logs. Now when you are keep on applying the archive logs, just recollect your recovery concepts. So generally archive logs will be applied when your database is in mount state for the entire database. So that is the reason in 9i our database always used to be in mount state. So in 10G, what Oracle has given as an option is, in 10G also by default it will be in mount state, but if required you can open your database in read-only mode for some time. So this option has been given in 10G. And when you open the database in read-only mode in 10G, this archeolog applying will stop. So archives copy will continue, means archives will keep on coming to the standby server, but because your database is not in mount state, archeolog applying will not happen. Again, when you place the database in mount state from read only to, again you change it to mount state, then that archeolog applying will start again. Means only for temporary time you can place your database in read only mode. Whereas when comes to 11G, Oracle has given a very good option that your database can be in read-only, and even archeologs will apply. So in 11G, when in 10G, when you place in read-only mode, archeologs will not apply. Whereas from 11G onwards, even if you place your standby database in read-only mode, still the archeologs will apply. So which means you can have your standby database always in read-only mode. Means all the select users can select the data from the standby database, and all the DML and DDL users can be connected to the primary database. So of course this continued same in 12C as well. Now this is also one thing that can improve the performance. Suppose any database will have three types of users or two types of users. One is select users and second one is DML or DDL users. So when you are creating a standby database in 11G, you can for all the select users, you can give the TNS entry as the standby environment, so that people will connect to the standby database and they will query the things. And for all the DML and DDL users, you can give the primary database entry so that they will come connect to the primary database and they will do the transaction. So basically, you are distributing the users between two databases, which obviously will improve some performance. But don't consider standby database is not a performance solution. Like some time back, somebody asked me a question in my Facebook that I am facing performance issues in my database. Can I implement DataGuard as DataGuard to improve the performance? But do remember, DataGuard is not a performance improvement solution. It is a disaster recovery solution. So what benefit you are going to get extra is performance. That's it. But the main role of the data guard is to have a standby database. That's it. So don't consider this as a performance improvement solution. So these are three different things that we have emerged from 9i to 10G and then to 11G. So that is what here it says is always running in the recovery mode. So when somebody says running in the recovery mode, it means it is there in the mount state. And in 10G we can open read only with it can be open read only, and in 11G it can be open read only with redo apply as well. And if you want the database, your 11G database, to be open read only as well as the the redo apply will happen, the archeologs applying should happen. For that, you need to purchase an extra license because that is called as active data guard. So the name of this concept is called as active data guard, and you need to purchase an extra license apart from enterprise edition cost for this to implement this particular feature. And then it talks about the patching things, so we'll be discussing anyway on that. So that's about the physical standby database. So when it comes to logical standby database, the name itself is telling you it is not an actual standby database. You are just assuming that to be a standby database. Logically, it will act as a standby database. So in logical standby database, what happens is like this. So you will have one primary database, and as I said, these transactions will go to redo log files and then will go to archeolog files. and with the help of the backup copy you will create one standby database. But this standby database, if it is a logical standby database, it will be open in read-write mode. So when it is open in read-write mode, people can connect to the standby database, and here also they can perform DML or DDL transactions. So the problem is when they perform DML or DDL transactions on the standby, that will not get replicated onto the primary. So only one-way replication is possible, either primary to standby. So it is not possible to replicate from standby to primary. And also here what happens is, what are the archeologs that are generated on the primary, those archeologs will be copied onto the standby. And on the standby, there is one process. So that process will generate SQL statements from these archeologs. And those SQL statements will be executed on the standby database. Why? Because you cannot apply archeologs directly here because your database is in read-write mode. So as I said, ideally it is a logical standby database, but users can connect and they can do some other transactions also on their wish. So that's the reason you cannot say logical standby is the exact replicated copy of the primary database. And as I said, in real time, very rare situations you will see people using logical standby because of the only reason that the data is not in synchronized. And there are some limitations as well for the logical standby database, like these types of data types and all are not are supported. So that is all about logical standby. Then Oracle has introduced something called snapshot standby database. So we will discuss more about this at later point of time, and we will see practically also. Okay. So what happens in the data guard environment? So as I said, the transactions will get replicated to one or more standby databases. So then we have different types of modes that we will see here. Yeah, we'll talk more about it. So anyone having questions?
So, Pawan, this data guard, this software, right? It's a software. So you're going to install it on the primary database or on both, standby as well as the primary.
Basically, first to clarify, it is not a software. So whatever the regular database that you are using, the same thing, only with some parameter additions, you are going to convert that into a primary or a standby database. So no other extra software that you are installing. Whatever the uh, database software that you are installing initially, the same thing that we are using now.
So you want to say it's more of a configuration.
Exactly. So we are going to, we have parameters in SP file, right? So basically, with some modifications to that parameters, we are going to convert our database either into a primary one or a standby one.
Okay, got it. So here you just purchase a license, correct? So you purchase a license and you can use it.
Yeah, of course. For enterprise, as I said, this works only in enterprise edition. So you need to have a license for that enterprise edition.
Okay, got it.
So any other questions from anyone? Okay, so let's talk about the protection modes. So depends on the requirement of, depends on your requirement or the business requirement. Oracle has designed three different modes of working in this data guard environment. So we have something called maximum performance, maximum protection, and maximum availability. So let's go and see like what are they and what are the benefits each and every mode will give us. So maximum performance is the first one and the default mode. So if you don't mention anything and you create a standby database, by default it will be created in maximum performance mode. And it says it provides the highest level of data protection without affecting the performance of the primary database. So how and all, once you complete all the modes, then you will understand. And the main important thing is primary database does not wait for an acknowledgement from the standby database. So we'll discuss about it, then you will understand more clearly. Now this is the maximum performance mode architecture. So what's happening over here? So as I said, from the backup of the primary database, we'll be configuring the standby database. And after that, what these things or how the things will work in max performance mode. So whatever the transactions that happens in the primary database, obviously will generate redo entries, and those redo entries will come down to archive log files. So archiver process will take care of generating archives, and whatever the archives that are generated on the primary server, those archives will be copied onto the standby server by two processes. One is called as log network service, which runs on the primary database, and second one is remote file service, which runs on the standby database. So just to change here, it should be and not R. So both LNS as well as RFS will take care of this activity. So LNS stands for log network service, which runs on the primary side, and RFS stands for remote file service, which runs on the standby side. So these two will take care of copying the archives from the primary to standby. Once an archive has been copied onto the standby, there is another background process called MRP, Manage Recovery Process. So this background process, whenever it detects a new archive log file in the destination, immediately it will apply that particular archives to the standby database. So making the standby database data to be in sync with the primary database. So this is what will happen in the maximum performance mode. So to give an example, so this is primary database and archeolog files are generating in some particular location, let's say U03 prod.db. So I'm just taking an example, 16th archeolog file, 17th archeolog file, 18th archeolog file, like that. So whenever 16 is generated, then immediately that will be transferred to the standby with the help of these two processes, LNS and RFS. And let's say on standby it is located in some other destination, U02 standby. So once this 16 archive file is copied onto the standby, MRP will detect that, and immediately that MRP process will apply that archeolog file to the standby. So let's say this happened at 10 o'clock. At 10 o'clock 8 minutes, 17th archeolog file generated. So without any delay, immediately this file will be transferred to the standby, and again that will be applied. So let's say 1020 18th archeolog file generated, again that will be transferred and that will be applied. So like this, whenever new archeolog file is getting generated, immediately it will be transferred and that will be applied onto the standby to make standby in sync with the primary. So here primary database doesn't bother whether the archeolog file is being copied or not, or whether the archeolog file is being applied by MRP or not, or whether standby is in sync with primary or not. So primary will not bother about that. It will keep on doing its own work. So that is the reason this is called as maximum performance mode, because the performance of the primary database is not affected with this architecture, because only other background process are taking care of the activity. So the existing background process of primary like dbrater, lograter, or smon or archiver process. So these no background process of primary is involved in the maintaining the standby database. So that's the reason primary performance will be remain as it is. Just like how you have a regular database without a standby database, the same performance will be there on the this database as well. Because as I said, primary doesn't bother about the standby database here. So that is the advantage. Now let us look at the not exactly a disadvantage, but what happens if there is a network disturbance between primary and standby. Because as I said, primary will be located in one particular location and standby will be there in another geographical location. So because they are working in two different geographical locations apart in the world, so obviously sometimes there are chances that network will get disturbed, maybe a few minutes of time. So what happens during that time? Let us go and understand that. So archeologs will keep on generating in primary. So let's say uh, at this particular point of time, assume that both the primary database and the standby database are in sync. And there is a so the let's assume the time is 10 a.m. and there is a network disturbance occurred between primary and standby. So which means whatever the next archeolog files generated, so some archeolog files generated here, assume that. So whatever the archeologs generated here will not be copied onto the standby because network is not available. So now at this moment of time, whenever there is a network disturbance occurred, immediately two new process will be activated. So one process name is called as FAL server, which will be activated on the standby side, and another process name is FAL client, which will be activated on the primary side. And whereas FAL stands for fetch archeolog. So FAL stands for fetch archeolog. So shortly we call it as FAL server and FAL client. So FAL server process will be activated on the standby and FAL client process will be activated on the primary. Only when there is a network disturbance. If there is no network disturbance, these two processes will remain in sleep mode. Now let's say uh, the last archeolog that was transferred and that was applied is 112, and after that some archives generated like 113, 114, etc., etc. Now the latest archaeolog file that was generated is 121. So let's say by 10:28, I'm just taking the times. So by 10:28, assume the network got re-established. So again, the network got re-established at 10:28. Now there is a gap between the primary and the standby database, because your standby database archaeolog is 112 in terms in time. If you look at your standby database, time is still 10 a.m. means the data on the standby database is still at 10 a.m. So whereas the data in the primary is 10:28 a.m. Now somebody they should be there to sync this standby database with the primary database, and that responsibility will be taken care by this file server and file client process. So once the network got re-established, file server will check what is the last sequence number that was there in the archive destination. Then this file server will send that particular communication to file client. So it will send a communication with the number 112. Then file client will check whether there are any archives greater than 112 in the primary destination. Yes, there are archives more than or greater than 112. Then file client immediately will initiate log network service to transfer these archives starting from 113 to 121. And of course, LNS will get in touch with RFS process, and the archives will keep on copying to the standby environment. And of course, once the archives are in place, MRP process will apply them. So MRP process will apply those archives. And once the standby now, like let's say last archaeolog, that is 121, is also copied and MRP applied, and your primary and standby databases are in sync. So the moment primary and standby are in sync, immediately this file server and file client process will again go to sleep mode, which means those two services or those two processes will be activated only when there is some disturbance and there is a gap between primary and standby. If everything is going smooth, then these two processes again will go to sleep mode. So here if you look at, even there is a gap between the standby database and primary database because of network disturbance. As a DBA, we are not doing anything manually. Everything is being taken care automatically by Oracle itself. So automatically these two processes are being activated when there is a network disturbance, and automatically once the network is available, the things are getting resolved. So that is how the things will work in the maximum performance mode. So with respect to interviews, they might ask you to explain how this max performance mode will work, and definitely they will ask you the question about file server and file client. So they may directly ask you a question, what is file server and file client, or they might ask you indirectly how the gap between the primary and the standby will be resolved in case of a disturbance in the max performance mode. Then you need to tell that file client and file server process will take care of synchronizing both the primary and the standby databases. So is that clear? Anyone having questions? Okay, so let's take a situation here, similar situation. So primary database, then we have standby database. Archeolog files are keep on generating, and there is a network disturbance. I'm taking same example, and 112 is the last archeolog file that was copied onto the standby and applied, and after that some other archives generated here, and right now the time is 10:28 a.m. Now at this moment, as we discussed, file server and file client will be activated. So here file server and here file client. So both are activated. At this moment of time, assume due to some reason your primary database got crashed. So the server itself is down. Not only the database, due to some reason, the entire database server is down. So obviously, as a business continuity plan, you need to open the standby database for the user access. So if you want to open, or you can open the standby database, that's not a problem. But the question here is, do your standby database having all the data what is there in the primary? No, we don't have, because our last archeolog file, or the time at which the last standby database is there, only at 10 a.m. So it is not having all the data what the primary database is having. So primary database is having some 28 minutes extra data. So that data is not available on the standby database. So if you open your standby database now for user access, it means that you are going to lose 28 minutes of data. Now, how to handle this kind of situation? So here, if you look at, your importance is more for your data, not for the standby database. So whatever the mode it works, I don't bother, but my data is important. So whatever the data that is there on the primary should be there on the standby, and whatever the data that is there not there on the standby should be not there in the primary as well. When I say, so understand this logic, very important. Suppose I have one value called 100 in a particular table. It should be there even in the standby database. Likewise, if I don't have some value here, let's say in the same table, I don't have a value of 90, which means that value should not be there in the primary as well. Then only we can say both are in sync. So how we can avoid such kind of data loss is with the help of next mode, that is maximum protection mode. So in maximum protection mode, the data protection has been given more importance than the performance. In earlier situation, I told you that your performance of the primary database will remain same, as primary database doesn't bother about standby database. It doesn't care whether standby is in sync or not. But in maximum protection mode, because we are saying data should be same between primary and standby, your primary database will look after the standby database as well. So earlier situation, primary database is not bothered about standby, but in this mode, primary database is bothered about the standby database. So that we call it as maximum protection mode. So how this is going to work? So tomorrow we will see it, and there are two different I mean new enhancements also there in 10G and 11G versions to it. So we will try to understand what exactly happens in the max protection mode tomorrow. So hope I am able to explain it clearly. So anyone having questions? Okay, so let's meet tomorrow at the same time.
Pawan, this is Sachin here.
Yes, Sachin, please.
Oh, Pawan, yeah, Friday I couldn't attend the class. Can you send me the video?
Friday?
Yeah, Friday I did not attend the class.
Okay, okay, fine.
Okay, thank you. Yeah.
Okay, guys, so let's meet tomorrow at the same time. Have a nice day till then.